right, section 6.3, we're going to take a couple days for it. So, and we're going to be talking about logarithms and logarithmic functions. So the inverse of the exponential function y is equal to b raised to the x power is the logarithmic function x is equal to log to the base b of y, where b and y are positive real numbers and b cannot equal 1. So example 1, write each equation in exponential form. So I left a lot of room here on the first one so I can kind of show you how you should do it. All right. So I'm going to rewrite it here for you. So I'm going to write log to the base 3 of 9 is equal to 2. So what you need to kind of tell yourself is this. This base raised to this power equals this. All right. So let's see how I just said that. This base, so 3 raised to this power 2, or 3 squared, that equals 9. And of course, ladies and gentlemen, you know that one is a true statement. So we're going to do the same thing with the other ones there. So again, log to the base 6 of 216 is equal to 3. So again, think this base, 6, raised to this power, 3, is equal to 216. This base, 7, raised to this power, is equal to 1. So 7 raised to the 0 power. Remember, anything raised to the 0 power is equal to 1, so it's definitely still a true statement. And still, even if I have a fraction there, so log to the base of 1/5 times 5 is equal to -1. So even on that one, I can write this base, 1/5, raised to the negative first power is equal to 5. And we know that is a true statement. All right? So you want to think the opposite when writing exponents in logarithmic form. So on this one here, example 2, write each equation in logarithmic form. So again, just think this base. So what was my base? And this one here, it's 9, right? To this power, that would go there. And then we would put the 81 there. And you can always look, does 9 squared equal 81? Yes. All right. So we're going to do the same thing for the other ones. So log the base 20 of 5/100 is equal to -1. And same thing on this one here. Log to the base of 16 times 8 is equal to 3/4. And again, you can always just look, this base raised to this power equals this, right? So this base raised to this power equals this, which is what we started with, all right? So pretty straightforward on these. That's why I kind of like these ones. They're fun, okay? All right, so evaluate means to get an answer, so set the expression to x, right? So if it says to evaluate each logarithm, go ahead and just set it equal to x. And then you're going to say the same thing like we were just saying. This base 8 raised to this power, x, is equal to 64. So now, think about 64. How can I write that in terms of 8? Well, isn't 64 just 8 times 8, or 8 squared? So again, same thing here. If the bases are the same and they're on opposite sides of the equal sign, we know that the exponents have to be equal. So we can say, in this case, that x is equal to 2. And you could always plug it in your calculator just to make sure. All right? Same thing here. We're going to put it to x. So now on this one here, we're going to say 1/3, right, raised to the x power is equal to 27. So now you're going to have to kind of think a little bit about this one here, because I have a whole number here and I have a fraction here, right? So I have a whole number here and I have a fraction here. But if you think about it, I can write that 3 cubed is equal to 27. Would you agree? All right. So how can I write it so it says that 1/3 x? All right. And so again, I want the bases to be the same. Well, if you think about it, I can just make that be a -3 there, right? So then if that's the case, then we can say that x is equal to -3. Okay. So just a couple real quick definitions. A common logarithm is a logarithm with a base 10. So log to the base 10 of x is equal to log of x. So on some calculators, all right, on some of them, if you just put log, a lot of them will put a little screen down here and you would put it to the base 10. All right. Some of them don't have that. Some of them do. I noticed on Desmos, it doesn't. But let's go ahead and look at it real quick here because I do have Desmos here set up for you. So I can write that on either one here. So I'm going to go here. All right. And again, notice how my thing came up. And on these ones here now, you're going to want to go to functions. So when you go to functions, you're going to be on the miscellaneous here. And as you can see, there's the log right there, and there's the log to the base of a, right? So remember, if it's just log, it's to the base of 10. So I'm going to show you that we're going to get the same thing. So I have log there, and I'm going to take 100, and it's equal to 2, all right? If I take log, if I use the other one, so this one right here, if I do log, notice how it left it there. So I'm going to do the base 10 there. And if I put 100 in here, notice I get the same thing. So like I said, some calculators, when you do it, it automatically puts this little area right here, this 10 here, right? And you're going to have to put it in. Some of them, it'll put like a little square there, like I just showed you on the notes, and it'll just leave it. All right. So just think about that. It's pretty straightforward. Okay. And then a natural logarithm is a logarithm with base b. So again, what we'll see there is we can say that the natural log of 10, and I'm going to show you again on the same thing. I'm just using 10, and I'll tell you that's 2.303. All right, so I'm going to do the same thing on that real quick for you. Okay, so in this case here, let's go ahead and they have log to the base e of x. So let's go ahead and do log here. And then again, remember, I'm going to go here and I'm going to put an e there. And on the other one here, I had 10 up here, right? And notice how it is kind of 2.303 if I rounded it up, right? Okay. And the same thing, if I use the natural log on the functions here, that's what it's called, is the natural log. It's that one right there. And if I use 10, I'll see we do the same exact thing. Okay. So let's go ahead and look at the ones here. So if we have log to the base of 21, again, you can do it in your calculator. All right. I'll do it here real quick for you. And then I'll do natural log of 0.54. So I'll do both of them here real quick. All right, so our first one here, what I tell you was log of 21. So in that one there, I just can use this one because again, remember it's to the base 10. And if I plug in 21, I get 1.322. Yeah. And then I told you I'm going to do the natural log. So natural log is ln. And on that one, I told you I had 0.54. And on that one, I do have negative 0.616. Okay. So I just did the last two there real quick for you. All right, that's it. Okay, I broke it up into 2 days. You'll find that this one goes rather quickly. Okay.